Hi everyone, my name is Thomas Favale and I'm a PhD student here at Politecnico di Torino. My research activity is focused on traffic anonymization, and today I would like to introduce you my tool, which is called Alphamon. Alphamon is a tool that applies traffic anonymization in order to prevent disclosure of user information. Nowadays, with the increased number of devices connected to the network, like for example laptops, IoT devices, smartphones for instance, it is important to apply and provide a greater security on the network, and also apply some traffic management in order to make them healthy. The problem is that in order to do this, we should apply some traffic monitoring. These monitorings consist in collecting packets from the network, and each packet contains potential sensitive information of all the users. So in order to protect user information, we apply anonymization. The most important approach is the key anonymity. The problem is that it needs all the dataset, but from our application this is not possible. We want to act like this. Here you see, for example, a pit stop from Formula 1. The car arrives. When it arrives, everything is changed and then it moves over. This is what should happen on our approach. The packet should arrive, everything should be changed, and then it should go out, in order to have all information completely obfuscated. In this way, we are sure that there are no information leakage, and we don't have all the dataset in our memory. This new approach is called alpha-anonymity. Alpha-anonymity works in this way. Let us assume there are some users that are visiting the website private.com, and we've set the threshold equal to 3. So, when user 1 arrives, obviously he is under threshold, and no information can leak. The same thing happens if user 2 arrives, and if user 2 and user 1 comes again, obviously we are still under threshold, since we have always the same users. But when user 3 arrives, he is the third different user, and so we can consider private.com as a common website, and information in this case can leak. After some time, let us assume that the delta t have expired, and so if user 2 comes again, he can be considered as a new user, but since we are still under threshold, no information in this case can leak. So what we have learned from this information? We learned that popular websites like Google, Facebook are responsible for the majority of the traffic. So letting these names of the popular domain in clear poses no challenge. So let's talk about Alphamon. So what about the raw performances? Well, as you can see from this graph, here we have the processing speed of a typical workload trace. So as you can see, with just one core we can reach the 10 gigabits per second benchmark. Finally, there is the DNS trace here. As you can see, we get maximum 3 gigabits per second with 8 core, but of course here we need a lot of passing for the DNS protocol, and then we need to update all the data structure. So this is Alphamon and my main research activity. Now we are searching for new ways in order to get more performance out of our software, and we are studying how the alpha-anonymity can impact on the privacy point of view, in order to understand if it can compete with the common approaches used today, and if there is a really good potential inside this new approach. So I would like to thank you, and take care.